going to look at properties of the cofunctions. Another name for cofunctions is complement functions. I maintain that their sine, so the sine of pi over 2 minus x and the cosine function of x, they are cofunctions because these two angles are complementary. You add them up, pi over 2 minus x, but then you add the x back, you get pi over 2. Two angles are said to be complementary or complement of one another if their angles add up to 90 degrees. Now, why is this obviously true? Well, let's look. You have a right triangle. You have angle x, and the other angle, since the three angles add up to pi over 2, the other angle must be pi over 2 minus x. Well, let's call this A, B, and C and get our hands dirty. The cosine of x is equal to, so you go to angle x, it's the adjacent over the hypotenuse. B over C, done. The sine of pi over 2 minus x, well, go over to pi over 2 minus x. The sine is the opposite, which is B, divided by the hypotenuse, which is C. Ooh, we got the same answers. That means this equals that. Done. Let's do another pair of complementary functions. Suppose we're looking at the tangent of pi over 2 minus x versus the cotangent of x. I claim that those two are equal. Get our hands dirty. Here, let me just try to say here I'll put x, and over here I'll put pi over 2 minus x. Remember, if this is pi over 2, 90 degrees, then these two have to also add up to pi over 2. And they do. So if I call this A, B, and C, well, the tangent of pi over 2 minus x, tangent of this angle, is opposite over adjacent. B over A. It really is. And the cotangent of x is, so I go to x, cotangent is adjacent over the opposite, which is also B over A. Therefore, these two are equal. That one's done. Notice that these all have co in their name. The other side doesn't. So I'm going to look at secant of pi over 2 minus x versus the cosecant. The cosecant of x. Draw a right triangle. Here is x. Pi over 2 minus x. This is the right angle. A, B, and C. The secant of pi over 2 minus x. The secant of any angle is the hypotenuse over the adjacent. Now, with respect to this angle, that's the hypotenuse always, and B is the adjacent. Now, the cosecant of x, this is the hypotenuse over the opposite. Oops, forgot to put x in. The cosecant of x. So with respect to x, C is still the hypotenuse, and look, The opposite really is b. So we established that. Now let's have a little bit more fun with this. That's what it's all about, having fun. Well, notice that these three angles are pi over 2 minus x, and these three angles are x. Well, let's make some kind of substitution. How about we let u equal pi over 2 minus x? Well, algebra will tell us that x then is pi over 2 minus u. Okay, so let's look at the first one. You have the sine of, well, I want to write everything in terms of u. So pi over 2 minus x, why that's just u. Okay, and this is equal to the cosine of x. That x is pi over 2 minus u. And the tangent, well, that's u. And this is equal to the cotangent of x, which is pi over 2 minus u. And the secant of this, well, that's u. And it equals to the cosecant of x, which is pi over 2 minus u. Now u is just a dummy variable. I can call all the u's whatever I want. And for right now, I like to call them x. All the u's are x's. And I get three other relationships between cofunctions. Nice quick video. That's the end of the cofunctions. I showed a relationship between each function with its cofunction. I showed cosine x is related to sine x. Cotan x is related to tangent x. Cosecant x is related to secant x. And sine x is related in a different way to cosine x. Same with tangent and secant. See you in the next video.